Good everyone, it is your favorite tutor, and today is your favorite tutor on physics. Okay, our topic for today is electric field. Electric field. It's a very simple definition. Electric field. Now, from the word field, what do we understand by the word field? Talking about field, for instance, field. We're talking about a space reserved for an event. Let's use football field, for example. Football field. Let's say this is a what? Football field. Now, this is a space reserved to play the game football, the sports football. Outside this space, outside this space, there is no game of football. But within the space, we can play the what? The sports football. Now, this space is the what? The field for what? Football. Now, back to what? Electric field. Talking about electric field, we are talking about a region or space covered with electricity. That is for what? Electric field. Now, I have a definition on the board. Okay, just take down this definition. It says an electric field is defined as a region or space where a charged body experiences an electric force. Okay, if this is an electric field, now this field is covered with electricity and is what? Positively charged. According to the definition, where a charged body experiences an electric what? Force. Now, this is what? Positively charged. This is the field. Now, within this field, if we place a what? A charged body right here in this field, we'll observe a what? An electric what? Force. Now, this field is positively charged, covered with electricity. Place a charged body right here. The kind of force we're going to observe is the force of what? Repulsion. Acts of the field. Force of what? Repulsion. It's just like taking two live wire. We join two live wire together. What do you think happened? It's going to do what? Spark. According to the word law of electrostatics, live charges do what? Repel, while unlike charges do what? Attract. Also, electric field can also be what? Negatively charged. Now, if we place a what? A charged body within this field, we experience a kind of electric what? Force. That's the force of what? Attraction. In this case, we have the force of repulsion, while in this case, we have the force of what? Attraction. So please take down this definition. An electric field is a region or space where a charged body experiences an electric force. Okay, now there are field lines. This field can be represented with what? Field lines or the lines of force. Now, these lines, they are imaginary lines drawn around the word electric word field. Now, this line shows the word the direction of the words the field. Okay, right here I have a word an isolated word positively charged field. Okay, these are the field lines of an isolated positively charged. But now these are the field lines. They are imaginary lines. We assume that these lines are present there. It's based on assumption, imaginary lines. And then this line shows the words, shows the direction. You can see the arrow. The lines have the word, the arrow. For positively charged, the arrow are what? Outward. Outward. It shows the what? The direction. That is from what we have here. Positively charged. The lines right here are what? Outward. So that is, if you place a what? A positively charged body here, we have a what? A force of what? Repulsion. And also, a what? An electric field can also be what? Negatively charged. For a negatively charged body, the field lines have the what? The direction inward. Inward. That's the direction inward. You can see the arrows. They are what? Inward. This is for what? Isolated, positively charged. Why this is isolated what? Negatively what? Charged. I'm going to give another illustration, then we take properties of the what? The feed lines. That is this what? Imaginary lines. Okay? Okay, what I have on the board. Now, think now if you these are examples of what? The lines of force, the way they are being represented. Now in this case, these are feed lines around two positively charged. That is two like charges. The feed line is between two like charges. Now, one thing according to the law of electrostatic, if like charges do what? Repel each other, while unlike charges do what? Attract each other. This field is positively charged. Why this field is what? Positively charged. If they come together, it's going to create what? Repulsion. They don't what? Attract each other. They don't attract. Now this is what? A perfect what? Explanation about like charges. Now, look at this other one. One we have here. Unlike charges. There is what? Attraction. Attraction between the two of them. Now, in this case, the field right here is positively charged. You can see the arrow pointing what? Outward. While the field right here is what? Negatively charged. You can see the arrow pointing what? Inward. Now, this arrow shows the direction of the what? The field, the force. Okay. Now, when they come together, there is this one, attraction. Attraction between both of them. They come together, we have this word attraction. Now, this is what? A perfect example. Remember that these field lines, they are imaginary lines. They are not there. Not when we look at electricity now, we expect to see lines of force. No, they are imaginary lines. Now, the line shows the what? Carries the what? The direction of the what? The force. Just like when we touch. Please don't play with electricity. When you touch a what, an a charge electric and metallic and charge electric and body. What happens is that we have this force of what? Attraction, because our body is what? A metallic conductor. Now, this is what we have right here. Like charges do what? Repel each other, while unlike charges do what? Attract each other. Now, these feed lines also have what? Properties. These are the properties. I think they are up to 6. Okay, we are going to take them one after the other. The first one says, lines of force start only on positively charges and end only on negatively charges. Yes, start on positively charged and end on what? Negatively what? Charge. Okay. Number 2 says, lines of force do not cross each other. They do not what? Cross each other. Like for example, the positively charged coming towards this direction. Okay, let me give an illustration right here. For example, this is the positively charged, and this is the what? Negatively charged. No, they don't cross each other. They don't cross each other. They must align to one another. Like for example, we have the positively charged, the negatively charged. They don't cross each other. Okay, number 3, another what? Properties. In a uniform electric field, yes, we have the uniform electric field and we also have the non-uniform electric field. But in a uniform electric field, the lines of force are straight, parallel, and uniformly spaced. The lines of force, it is a uniform electric field. Lines of force are what? Straight. They're straight, parallel, and what? Uniformly spaced. The space between each other are what? The same. That is, we are talking about the uniform electric what? Field. Okay. Number 4. Lines of force indicate the direction of the electric field. Yes, they indicate the direction of the electric field. For positively charged, it is outward. Is the direction, it takes the arrow. The arrow is what? Outward. For negatively charged, the arrow is what? Inward. Okay. Now, 5 says lines of force are continuous in any given region with free charges. Yes, they are what? Continuous in any. Yeah, they are just there. So long their charge is right there, is what? Continuous. Number 6, the closer the lines of force are together, the stronger the electric field in that region. Hmm. Okay, let's say, for example, something like this. The closer the lines of force, something like this, and something like this. Okay. Now, in this case, let us say this is one of your household electric wire, tiny little electric wire. Okay. The lines of force are space, isn't it? Right here, they say that when the lines of force, their closeness to each other shows the what? The strength of the electric field. The strength of the what? The strength of the electric field, or how strong the field is, right here. Now, in this case, the lines of force are space, so this field might not have too much strength, while this field has a lot of what? Strength. Like the magnitude of electric field force here, let us say is low in this case. Why in this case is what? High. Because lines of force are close to each other, while here lines of force are not too close to each other. Let us say, for example, your household tiny electric wire at home. Okay. If we place a metallic conductor here, this is your household wire, tiny wire from your house. If we place a what? A metallic conductor, we are talking about what? A material that can conduct electricity. For example, human body, your hand, is a metallic conductor. If you place a metallic conductor right here, in your household tiny little wire that you find at home from the socket or whatever, place your hand here. There's this force of what? Attraction. Your hand is what? Negatively charged, while the body is what? Positively charged. You touch a what? A live wire at home. There's this force of what? Attraction. uh Now, by the grace of God, you can pull your hands away. By the special grace of God, you can pull your hands away. Reason be that it may be that the field lines around that region, they are not close to each other. So the strength of the electric field is not too strong. You are stronger than the strength of the electric field. So therefore, you can easily pull your hands out away. Now, but for this case, let us say this is the what? A charge body from the transformer, maybe along the street. uh You place your hand right here in a transformer where the electric strength right there is what is very strong. You place your hand right there. By the grace of God, by the special grace of God, you will be waiting for us in heaven. Because right here, the field lines are close to each other. So, according to one of the properties right here, Yari, the closer the lines of force are together, the stronger the electric field in that region. Please don't play with electricity, because most electricity, the field lines found right there, they are close to each other. That's why in most cases we touch an electric, we see incidents whereby human being touch an electric wire, live wire. He find it difficult to pull his hands away, because why? The strength of the electric force right there, it has a massive attraction towards that field. So be conscious. Don't play with what? Life wire. All right. We have come to the end of this what episode. Please stay tuned. We'll continue from current in our next episode. Thank you and God bless you.